Welcome to your first video lecture. So in this lecture we're going to look at basically what is physics, introduce you to the topic. What is physics? Physics is the study of motion, and as you should remember from chemistry, the only time when something is completely not moving is when it's at absolute zero. And since nothing in the universe naturally occurs at absolute zero, that means there's nothing in the universe that is not moving. Therefore, physics is basically the study of everything in the universe. It's the foundation of most of the sciences. We divide this up into multiple different disciplines. The first one is mechanics, and mechanics is the study of macromotion, or the motion of large objects or objects themselves. This includes everything from kicking a ball, to moving a person, to moving a car, to moving a moon, to moving a planet, to moving a solar system, to the rotation of an entire galaxy, or even the whole movement of our entire universe. So that's basically mechanics. Thermodynamics is micromotion. As you may or may not remember, temperature is a measure of the average kinetic energy, and kinetic energy is the energy of motion. So when you're actually studying temperature, you're actually studying the motion of the atoms that are inside the object, or you're studying the motion of the electrons, protons, neutrons, those sort of things. So we call that micromotion, or motion on the atomic level. Waves is the study of repetitive motion, things that happen over and over again. Optics is the study of motion of photons, or the study of light waves. Okay, we don't cover that in this class. Electromagnetics is the study of the motion of electron. So electrons, or electricity, is the flow of electrons, and if you actually take electrons and you flow them, push them through a wire, you can create a magnet. That's why we call it electromagnetic. You can use electrons to create a magnet, or you can use a magnet to move electrons, and that's electron motion. Quantum mechanics is quantum motion, or the study of the motion of quantum particles. Quantum particles are things like quarks, bosons, fermions. These are things that actually make up an electron or a proton, or that are smaller than that, and they follow statistical probabilities, which is why we say it's different from thermodynamics. In this particular class, what we're going to cover is mechanics, waves, and a small little portion of electricity, part of electromagnetics. Those are the three main things that are going to be covered on your test. Predominantly, it's going to be this one and how it applies to this. So basically, physics is everywhere in the universe, but we're only going to study a small portion of it. So how do we do physics? So physics is an experimental science. It is truly all done by experimentation. We use observations and measurements. We seek to find patterns or relationships, and then we try to explain those patterns and relationships, and we use them to then make predictions. Literally everything that we know in physics, we have learned by doing an experiment. We don't sit there and think about it and think, maybe it's going to move like this today. Maybe that's a possibility. No, physicists go out there and they make it move. They watch it move. They see what happens. It's one of the few sciences that is 100% experimental, and that you can learn and see everything that we've learned in physics. What language do we use in physics? We use the language of mathematics to describe our understanding. So mathematics is really a language. You say A equals B. That's English. A equals B. That's translating the language of mathematics into English. We use that language to talk about the universe. In fact, mathematics really is the language of the universe. That's why we always say it's the universal language. It applies everywhere in the universe. It operates the same. When we use that language of mathematics, we have to make measurements in our experiments to take our data. So we have agreed as planet Earth that we will use the International System of Units. In fact, there's one very distinct case where this didn't happen. There was a space probe being built by the European Space Agency and by NASA, the American Space Agency. And what actually happened is one group did their calculations in meters or in kilometers, and the other group did their calculations in miles. And what had ended up happening was a multi-million-dollar rover crashed into Mars because the two groups did not agree on the propulsion, and one had designed it to do one thing, not realizing that the other group was doing using the different set of units. So now today we have this international system of units. We actually call this the SI system of units because it's French for Système International. Okay, and the basic units that we will be using in this class is meters, which is given the letter small m as the abbreviation, and it measures distance. Kilogram, given the small abbreviation for kg, and it measures mass. No, the gram is not the International System of Units standard. It is actually the kilogram. Pay attention to that. The Newton, given the symbol of N, measures weight. Liter, given the symbol capital L, measures volume. And I'm sorry, the Newton is capital M, while these two are lowercase. Seconds, lowercase s, is the unit of measurement for time. So these are the units that we use so that we all agree across the globe. Modeling in physics. Physicists generate mathematical models derived from experimental results that describe specific phenomena. This is our whole goal in physics. We're trying to solve the universe. We're trying to figure out why things move the way they do, what causes them to move that way, and describe how they move to someone else. So we create these models that we make a bunch of observation and we say this is what we saw, so we have a model of it. It's a mathematical model. It could be equation, it could be a graph, it could be like a computer simulation, it could be a chart or a motion map or something like that. Those are all models, mathematical models that we generate. Then we take these models and we apply them to different situations to test and refine the model. We try and take that model that we've learned and we apply it to something new and we see if it still holds true or not. Well-tested and refined models may become laws. So after we've tested a law and we've refined it, it may or may not become a law. If it's been tested and tested and tested and tested and there's never been a case where it didn't hold true, it may eventually become a law, but there's no guarantee. Okay, so what do models look like in the high school classroom? Because we're going to seek to follow the steps of a regular physicist and do the same thing with our learning. Modeling in high school, we generate and use simplified models to explain our observations. What it means by simplified is we're going to focus on the relevant ideas. There are lots of little things that we have to think about, but we're just going to focus on the big idea. What's the macro motion? That's why we focus on mechanics in this class. If you're interested, you can go ahead and look up one of the favorite things of a physicist is consider the spherical cow. So the idea is that we don't want to consider the air resistance or all the different movements of all the different legs of the cow. So we basically take the whole cow and just say, pretend it's just a sphere, because that's easier to consider. So the spherical cow is a model of a particle that can then move without having to worry about the motion of the arms and the legs and the head and the floppy ears or the tail and all that stuff. So if you're interested, you can look that up on the internet. That's a common one. That's the end of this video lecture, but since this is your first video lecture, I need to tell you that in each lecture there will be a magic word. This magic word needs to be put in your notes in the upper right hand corner. That tells me when you walk in the door, I can ask to see that and I know whether or not you have watched this video. So it's very important for every video that you have that magic word in the upper right hand corner of your notes. For this video, the magic word is going to be modeling. See you in class.